Nice to see so many of you here. Sorry to keep you waiting. I'm Majd and this is Jofre. So we're platform engineers in PDX, Spotify's platform developer experience department. And we focus on building tools and systems that help make Spotify engineers more productive.
Yes, we both have been around 8 years at Spotify, working in different corners of these internal platforms. During this time at the company, we've seen a lot of growth and evolving. So that gave us a good perspective of the challenges that our engineers face on their daily life. Today we want to share with you how are we trying to address one of these productivity blockers with the help of AI. Let's take a look at how the problem looks like. So as a platform department, we focus not only on measuring productivity, we are also concerned about what gets in the way of it. That's why in 2020, we started a quarterly engineering satisfaction survey, we call it ingest, to get data and trends on these productivity boosters and blockers across all Spotify. Since the very beginning, and for every run, we've seen how issues with finding information or poor or missing documentation have been consistently in the top 3. What that means is that our engineers have to spend time looking across multiple systems to retrieve information. Let's look at how this fragmentation looks like. So, as a Spotify engineer, when you have some doubts, some issues, what do? First, we have our internal documentation, tech docs, where we have more than 10,000 sites. With this scale, it's not only difficult to keep all the information up to date, it's also difficult to find the right site that contains the information you're looking for. We also have code, lots of it. In GitHub, we have readmes, we have reference implementations and code examples that can save a lot of time for your daily tasks, scattered around 22,000 different repos. And when it comes to communication, we use Slack a lot. It's our main tool for internal support, teams to teams. So there we have a lot of our institutional troubleshooting knowledge. What happens with that is it's difficult to retrieve all answers that could answer your question. So teams have to balance a lot of their time between providing support and answering the same questions that get asked over and over again with their core work. That's not even mentioning all the rest of the information that we have in working documents, in requests for comments, in architectural decision records, in planning tools, in dashboards, etc.
Yes, so all of you are probably familiar with LLMs by now, or most of you at least. So 2 years ago, we saw GPT 3.5 and other advanced LLMs introduced us to new ways of interacting with information using natural language. And these LLMs, they could produce and understand human-like text, but they came with clear limitations. So early LLMs, they had very limited context windows, typically 4,000 to 8,000 tokens. And they often just made things up, so we all became familiar with the term hallucination overnight. And they were often very costly to train from scratch or even to fine-tune. So retrieval augmented generation, or RAG, emerged as a pattern to deal with some of these main limitations. Are you familiar with RAG? How many of you are familiar with RAG, by the way? I see about 30%, 27% maybe of you. All right, so RAG is a technique that allows you to do question answering over your own private data. And the process in RAG typically starts with a set of documents that contain useful information. These documents are split into meaningful chunks. And then using an embedding model, each chunk is converted into a vector representing its semantic meaning. These vectors are stored in a vector database, And then when a user has a question, that question or query is also converted using the same embedding model. So then the system can find relevant information by doing vector search or semantic search across the knowledge base. So this addresses some of the main limitations by retrieving only the most relevant documents. So you don't overcome the context window limit. And this approach is also more cost-effective, right? Because you're only dealing with a subset of information instead of using the whole knowledge base. And it also addresses some of the hallucination issues by grounding responses in actual documentation. So at Spotify, we saw several teams, I think up to something like 8 different teams starting to build their own RAG solutions early on. So this meant we had duplicated efforts. There were few or no best practices. Infrastructure and knowledge wasn't being shared between solutions. So there was really a need to create a single robust platform for RAG. So our team was formed, and we were tasked with creating a single platform for knowledge ingestion and serving, and to create recognizable patterns and identities across Spotify internally. So in doing so, we established some core principles, mainly trust from transparency. So we recognize that we're an aggregator of information, so we're not a source of truth, but users always have to be able to verify where the information comes from. And we believe there is a strong synergy here where better documentation leads to improved responses, and better responses incentivizes teams to update and maintain better documentation. So this leads to a positive feedback loop. And we wanted the platform to support multiple experiences and be adaptable to various knowledge domains. We wanted to allow users to customize the experience, and we wanted to meet users where they are, so to allow different interfaces in Backstage, in Slack, in the IDE, and so on. So these principles guided our development and help ensure that we build a platform that's useful as it grows.
So yeah, meet Aika, our artificial intelligence knowledge assistant. Here you can see it in action, integrated into Backstage, our developer portal. Aika can retrieve, at this point, information from our key knowledge sources, which is internal documentation, all the conversations from Slack support channels, and our organizational data. And then it can blend all this context together to generate useful answers. But as Matt said, we don't want to focus only on Backstage. So here we can see it also, the other clients that we mentioned. We have a collection of clients. We want Aika to be a knowledge platform, powered all by this same knowledge backend. We have Slack bot, that's our Slack client, that is useful for private conversations and group conversations in channels. We have an API open to all our developers to be able to incorporate Aika capabilities into their applications and services. And we have also Python client library that makes it super easy to access all this knowledge programmatically. But let's see what Aika is capable of. Let's look at some examples. Spotify as a company has been around long enough to generate their own kind of lingo, their own set of abbreviations and jargon that can be a bit challenging for new joiners, or even when you're moving teams. Take this example. If you ask anyone, any model about MMA, they're most likely going to reference mixed martial arts. At Spotify, MMA stands for Managed Monitoring and Alerting. And here we can see how Aika can retrieve this information from our internal documentation and provide the contextually correct answer. Next, at Spotify, we have more than 600 teams at this point. Finding the right one to talk to, it's also not easy. In this case, we can see how Aika is capable to retrieve the owner of a specific feature based on a past Slack conversation. And lastly, despite Aika being developed to interact with our internal knowledge, it still holds the capabilities of normal large language model. Here we can see how we are asking about like a general Python question, and it's answering it without any problem. All these capabilities are very useful, not only for new joiners, also for experienced Spotifyers when they are venturing into a new domain. This can help when you have to both navigate new technical concepts and Spotify-specific implementations or conventions for this domain.
Yes, so in about a year, we've seen wide adoption of Aika at Spotify. About 70% of our employees have tried it at least once, but perhaps what's more telling is the sustained usage. So we just celebrated more than 1,000 daily active users. 25% of all our employees use it weekly. If you look at developers only, that number is up to something like 86%. But perhaps what's more interesting is the effect in behavior this has had, the positive feedback loop that we talked about earlier. So qualitatively, we've seen a lot of teams and users reach out to us for how to best make their documentation available through Aika. We've seen that users search for and find missing or outdated information and notify documentation owners about it. So this leads to improved documentation, which feeds back into Aika. Yeah, so we've seen a bit about what Aika is and what it can do. So what are some of the moving parts of the platform? Jofre talked about the different clients, ranging from Backstage to Slack to Python and so on. And architecturally, our solution is fairly similar to the standard RAG solution you saw earlier, but fine-tuned for our needs. So we have a main backend service responsible for orchestrating everything. We support several LLM providers and their frontier models. And we rely on several third-party APIs for things like re-ranking and embeddings during retrieval. And we have our own inference service. So for some use cases, we build custom machine learning models for example, for some use cases, we want to be able to determine if an incoming question requires internal knowledge or not. We also have a custom confidence scoring model that outputs a confidence score, 0 to 1, of how confident we feel that an answer is helpful based on the question, the retrieved documents, and the answer itself. And we have an evaluation framework, so we can evaluate and reason about things like retrieval accuracy and answer quality. And this helps us to move safer and make changes confidently. And all of this feeds back into our observability system. So using OpenTelemetry, we gather insights into everything that's going on. And this allows us to support users and to improve the service. And one of the decisions we made early on was to start small and build from there. So we started with a set of high-quality documentation and Slack channels. And as the platform proved itself, users wanted to add their own content. So we focused on building out our ingestion pipeline and allowing users to maintain their own data sources. But this growth isn't all without issues. See how this animation looks like with this Star Wars thing going on here. Yeah. This growth isn't without issues. So with a growing knowledge base, you can sometimes get semantically similar but irrelevant answers from other domains. So this visualization shows our embeddings space in 3D. And you can think of it as a map of our knowledge where similar concepts cluster together. So you might have, for example, back-end development over there and some organizational data over there. And each point represents a chunk of information. And the closer the points are to each other, the more semantically similar they are. And vector search generally gets you in the right neighborhood, where you can retrieve more documents than you need, and then re-ranking helps to distill that down to the most useful documents. But when you have knowledge from many different domains, so back-end development, web, security, and so on, they can sometimes overlap in quite unexpected ways. And while re-ranking helps to untangle this mess a bit, getting rid of the background noise helps even more. So this is the same embedding space, but here we've highlighted a specific region or a set of topics that are relevant to some discipline. So we found that often when users ask a question, they have a specific context in mind. So a back-end engineer, for example, asking about deployment practices is probably not interested in iOS deployments. So having all this knowledge in the same vector space is very useful for discovery, but the ability to narrow it down and to filter out noise unlocks new opportunities.
Yes, so we worked on implementing these capabilities, and now with the ability to filter the knowledge available, what we were able to do is expand from being a general assistant to creating a platform capable of creating focused experiences. Remember the early RAC initiatives that we mentioned before? Most of them were focused on internal support cases, so their teams wanted to automate away this answering of the repetitive questions, reducing interruptions and context switching, which is another productivity drain often mentioned in ingest. So now all these teams with the capability of filtering the knowledge available to all our clients were able to package a slice of all this knowledge space with their system prompt to create their customized assistant or experience. This allowed them to leverage all our infrastructure, being able to forget about chunking and embedding and ingesting and focusing only on what makes their experience or the assistant or the domain unique. But we still saw that a lot of the teams at Spotify have their support Slack channel. And what they really wanted to do, a lot of them, were to have some sort of automation there that could automate away their work, their support work. So that's why we created and platformized as Aika Goalie Bot, which is a standardized support solution for Slack, fully customizable by our teams. We kept the Aika identity, so all Aika users could be familiar with the interactions no matter what channel they were asking questions on. And goalie is because at Spotify, the goalie is the person monitoring a support channel, and they are in charge of handling everything from these more routine questions to long troubleshooting debugging sessions. So what we saw is the opportunity to let AI take care of this more boring work and let human goalies handle these more interesting troubleshooting sessions. So how does this work? When the bot sees an incoming question, the first thing to do is to decide if it's capable or not to answer this question. At this given point, questions like, can you please review my PR, are not suitable for the bot. But if we see that it's capable of answering it, what it's going to do is generate an answer, and using the confidence score that we mentioned before, it's going to do one thing or another. If the confidence in the answer is low, it's just going to stop here and do nothing. If the confidence is medium, it's going to propose this generated answer to the human goalie and let them decide how to proceed. And lastly, if the confidence is high, it's automatically going to post an answer, citing all the sources, as we mentioned, and save some time for everyone. What this means is saving literally thousands of hours that could be devoted now to main work. But we knew since the beginning that a one-size-fits-all kind of solution wouldn't work well here because each channel is slightly different, their technical depth is different, the quality of the documentation, and even the team's preferences. So what we did is we adopted a declarative YAML approach to the configuration of each channel, which allowed the teams to be in charge of all the parts, all the moving parts of this system. They could decide what knowledge is available to the bot, either documentation, their threads from past Slack conversations, or even their custom data sources. They could tweak the system prompt to decide on different particularities for their Goalie bot, and even the confidence, what is high, medium, and low. And yeah, we've seen how people has adopting this. It's been quite remarkable. Right now, we have it working on more than 100 support channels. And for us, what's more surprising and rewarding is that not all of them are from the R&D part of the company. Our approach to configuration without having to write a single line of code means that non-technical teams have been able to adopt this bot and benefit from it. On average, the Aika Goalie Bot helps answering 30% of the questions that it sees. And yeah, that's where all those thousands of hours come from.
Yeah, so what were some of our most important learnings and challenges when developing Aika? So first of all, we believe that retrieval is the most important part of RAG. Without finding the right documents or the right information, you can't really provide accurate answers. So naturally, a lot of the effort goes into the retrieval part of it. And vector search is coarse, right? You can think of it as casting a wide net. You retrieve more results than you need to make sure you don't miss anything important. And here we're working towards adding hybrid search to support some use cases better. And we found that re-ranking has been the single best improvement we've made. We've seen 10 to 15% improvement in retrieval accuracy when using re-ranking. And we learned that more context isn't always better. So in our measurements, when doubling the amount of documents in context, we didn't see significantly better results. And this is because the relevancy during retrieval drops off logarithmically. So you might see a lot of improvements in, say, the first 5 documents you provide, but then rapidly diminishing returns after that. And you often just end up filling the context window unnecessarily. And every data source really needs special consideration. And what do I mean by that? For example, some of our raw data exists in a graph structure. So we have data in many different formats. So if it's in a graph structure, it needs to be flattened and embedded in a useful way for question answering. And a single Slack conversation, for example, can be embedded in many different ways. So you really need to try to anticipate what kinds of questions your users want to ask of the data when ingesting. And perhaps one of the trickiest challenges is determining if something is a hallucination or if it's bad data. So when you have an incorrect answer, is it because the LLM made it up, or is it because it's correctly using outdated information? And that's why we always try to cite sources, so users can verify the information and notify documentation owners, so it incentivizes them to update stale information. All right, so what's next for us with Aika? We're evolving Aika through a set of clear phases where each one builds on the previous one. So what we have now is a solid foundation of semantic search across multiple knowledge sources. But our current solution relies on predefined data sources, right? So what we're working on now is enhanced reasoning. So instead of users having to know which data sources to query, the system can deduce automatically based on the query and the context the user is in, which data sources are relevant. And looking a bit further ahead, we see Aika evolving into a platform for agentic capabilities. So dealing with multi-part, multi-turn questions that require gathering information from many different sources, and perhaps even using tools to access real-time information and act on behalf of the user.
Yes, and to end for today, we've seen how this has helped a lot of our engineers. So we are happy to share with all of you that we are bringing these Aika capabilities to Spotify Portal, our managed solution for the Backstage platform. With this, our customers, we're going to be able to leverage easily all the really good information already available in their own Backstage environment. So yeah, that's all for us for today. Thanks for listening and staying until the end. Yeah, I don't know if we have some time for questions after but yeah, we are gonna hang around as well. We have also a QR code for feedback, or in case you want to retrieve the slides. Thanks a lot.
Yes, thank you.